Sitting in the morning sun, I'll be sitting when the evening comes, watching the ships roll in, and then I'll watch them roll away again, yeah.
Hi guys, so we're going to learn two new words today to do with trigonometry. And the first of those is angle of elevation. So when we meet worded questions, which will kind of give us a situation, they might use this phrase, the angle of elevation. And what that means is they say, when a person is looking, and if they're looking up, say, at this bird, this is their horizontal line, this is the line of sight, and this is the angle of elevation. So if they say the angle of elevation is 30 degrees and you're standing here, it will always be talking about this angle here, okay? So the one at your eyesight. So not this angle here, well obviously that angle there would be your 90-degree angle, and not this angle here. So the angle of elevation is if you're looking upwards, and what this angle here would be. The second one is called the angle of depression, okay? And again, like that, it's taken from the horizontal line and the line of sight. It's the little acute angle in between, okay? So when we're talking about questions, and it might say the angle of elevation is, you must associate that with this angle here, and if it's the angle of depression, it's this angle here, okay? So it's not going to be marked, it's going to use those words. So that's important information, and I need you to write that into your copies. Okay, so I'm going to take you through an example of a question that uses this phrase, angle of elevation. So a girl is standing 10 metres away from the foot of a radio mast. So a radio mast is really a massive aerial, so they'd be quite associated now, I suppose, with telephones. Using a clinometer, she measures the angle of elevation. So a clinometer is just something that people can use to measure angles. Okay, and if you do geography for your leaving cert and you're doing your field work, you'll actually have to use a clinometer. I'll show you a picture of one here now. Okay, so just a little side note, a clinometer is used to measure angles of elevation or depression. You simply use a clinometer with a protractor and a pen and some string, and you pull it along and it will tell you the angle. But anyway, we're back to this question now. So using this piece of apparatus, she measures the angle of elevation to be 70 degrees. So here's where she's standing. This would be her angle of elevation. Now it said she's standing 10 metres away from the mast, which means that's your horizontal line. Okay, this would not be 10 metres, it's the horizontal line here. And it says, find the nearest metre, the height of the triangle. So once they've given it to you in this piece of information, my first port of call would always be to draw out the triangle as I now understand it, okay? So as I now understand it, it's definitely a right angle triangle, okay? And I can use my knowledge on right angle triangles to solve. Okay, and I'm just going to make this a bit further down. And this one. Okay. All right, so we know that this is the height of the radio mast, so I'm going to refer to that as x. This is my right angle. I'm told that this is 70 degrees, and this bottom one here is the distance she is away, which is 10 metres. Okay, so once I've drawn that, the next thing I do is step one, I would label as I have done so far. So this is my hypotenuse, this is my given angle, therefore this is my opposite, and this is my adjacent. Step two is you're going to write down your ratios. So I'm just going to copy them in here. Okay, and someone asked me earlier, are they in the log tables? And I wasn't sure, but they are actually in the log tables. They're on page 16. But anyway, I'm sure by the time we've done this chapter, you will know them off by heart. But if not, at least you can access them that way. So once I've done step one, label, step two, write down my ratios. Step three is I'm going to choose which ratio I want. So I'm given the adjacent and I want the opposite. So adjacent and opposite, it's going to be tan. And generally, whenever you're dealing with angle of elevations, it is always tan. But anyway, we will just come to that conclusion by using our knowledge. So opposite, which is going to be x, over adjacent, which is 10. All right, okay, it says the tan of A, but that means the tan of the angle. And in this case, I am aware of the angle. The angle is 70 degrees, so it's going to be tan of 70 degrees equals x over 10. Now, you know what tan of 70 is? Well, even if you don't know, you can literally just type that into your calculator. Okay, and I've got 2.74. I'm then going to multiply this side by 10 because I want to get rid of this divide by 10. I'm going to multiply this side by 10 because that's what you do in balancing. My divide by 10 and my multiply by 10 cancel. I'm left with x, and if I multiply 2.74 by 10, I will get 27.4. It asks me to the nearest metre, so x, the height of the tower, is 27 metres. Okay, so that's a full question there on angle of elevation. Nothing different to what we were doing in class today, but suddenly there's a lot of words and there's the lack of the diagram, so you must draw your own diagram. So that's why it was super important to be doing that today. Okay, example 2 uses the new phrase that we've looked at today, angle of depression. So a coast guard is standing on the top of a cliff. He's standing at point C and he sees a boat S below. So once he's looking below, it's the angle of depression. Okay, the cliff is 88 metres high, so that's marked in, and the boat is 100 metres away from the cliff. Calculate to the nearest degree the angle of depression at alpha. Okay, so this is alpha here, and you can see that alpha is quite outside the triangle, all right, and quite difficult for us to figure out alpha. But what I'm hoping that you can see here is that you can actually see that if I was to extend these lines out, you would have parallel lines. This would be your transversal going through it. I just need to make that a little bit neater. And even though I'm looking for this angle here, this creates a Z line, and so this angle here is the same as this angle here. So, even though they're looking for the alpha here, we can make that the alpha here. And that's the angle we're going to look at. So, as I said, step 1, we're going to draw out our triangle. We're going to label what we know, and we're going to ensure that we have taken all of the information on board. Especially with junior cert questions, some of the information may be written down and not in the diagram, and it's up to you to put those together. So anyway, here's my right angle. I'm told this is 88. I'm told this is 100, and I'm asked to find this angle here, but that's an alternate angle for this angle here. So I'm going to find this angle here because that's inside my triangle, and that's how I can use sine, cosine, and tan. So step 1, label. So obviously opposite the right angle, this is my hypotenuse. Opposite the little angle here in the corner is your opposite, and the last one here is adjacent. I'm then going to input my ratios, and I'm going to say to myself, right, I have the opposite and the adjacent. So I'm looking for the angle, but I have the opposite and the adjacent, so it's tan again. So it is tan of the angle. In this case, the angle is called alpha, equals opposite over adjacent. Tan of the angle equals, in this case, my opposite is 88, so it's 88 all over adjacent, which is 100. Now I'm going to write that as a decimal. I'm just a little bit more used to seeing it as decimals, so that's 0.88. Now, I am looking for the angle. I do not want tan of the angle. If I could get rid of that tan, that would make my life a lot easier, because then I'd have the answer. How can I get rid of a tan? It's not a tan plus alpha, it's a tan alpha, which means it's a tan multiplied by alpha. So I can use this lovely button on my calculator called tan to the minus 1. And what that does is that if I multiply tan by tan to the minus 1, they cancel. But what I do to one side, I must do to the other. And so my alpha then, my angle, is going to be tan to the minus 1 multiplied by 0.88, which in this case, if I was to do that, the tan, or the alpha, is equal to 41 degrees. That means that this angle here is 41 degrees. We weren't asked for this angle here, we were asked for this angle here, but because they're alternate, we have solved. And that word must be written down, guys, for the examiner to understand that you knew what you were doing. Okay, learning check tonight. I need you to write both of those examples into your copies, as well as the new keywords that we learned, angle of elevation and angle of depression. You're also going to do this learning check for me. So Sarah, on level ground, paces out 100 metres from the base of a vertical tower. She then measures the angle at the top of the tower. Explain clearly how she could find the height of the tower. So you're actually just going to find the height of the tower for me. Please ensure that you have done your diagrams. And I'll see everybody tomorrow.